Great seeing you here. You finished lesson 3. This is the last video of lesson 3. And this video is about a quick review of all the things that we studied in lesson 3. And once this video is finished, you can continue with lesson 4. Now let's have a look at all the things that we discovered in lesson 3, all the things we learned about or you learned about. First of all, we are looking at the linear programming methods. And linear programming was one of those methods developed already during or before the Second World War. It was a very interesting method that provided us solutions to specific problems. The method was developed by two mathematicians, Leonid Kantorovich from the USSR and Vasily Leontiev from the USA. They made the first attempt to resolve linear programming problems in the 1930s. During the war, linear programming became very important when resolving transportation, scheduling, and resource allocation problems. Finally, in 1947, the simplex method was developed for minimization and maximization problems. We've discussed these items, and when we look at linear programming, the theory is based on linear inequalities. Linear inequalities which are in fact linear equations, but instead of an equal sign, we have an inequality sign which identifies a part of the plane to be compliant with the conditions of the linear inequality. The next thing that we did is that we tried to find different equations for maximization and minimization problems. And here we see an example of the results of a maximization problem where we have the different parameters and the different linear inequalities equations that describe this problem. Also notice that there is a non-negativity condition, or there are non-negativity conditions for this problem. Then we looked at the graphical solution. We put all those equations into an x and y graph when we have a two-dimensional problem, and we find what we call a feasibility zone, where all the points of the feasibility zone comply with all the linear inequalities that describe our problem. We also have a solution here when we look at the corner methods, corner point methods. The corner points are points that probably will entail a solution. For a maximization problem, we calculate the value of the objective function, which should be maximum, and for the minimization problem, we find the minimum value of the objective function, which describes the optimal solution, for example, the lowest cost. We also look into the possible issues with linear programming. First of all, we have the problem of infeasibility. We have the unboundedness, which is typically a problem when we have maximization problems. We look at redundancy, where we have certain inequalities which basically do not add anything new. They are redundant. We can remove them from the solution. And we also have cases where we have alternate optimal solutions. For example, infinite possible solutions that make it more difficult to make a selection. So these are some issues that we also described in this lesson. So that's it for lesson 3. Basically, we've seen all the different items, the main items that we discussed in lesson 3. Now you're ready to start with lesson 4, and that's a great step forward because you already finished 3 lessons. I thank you very much for your participation. I hope you enjoyed the video, and I'm looking forward to seeing you in our next videos. Thank you, and bye-bye.